All right, let's talk about the secret language of data. It all boils down to one simple, fundamental concept that is the absolute bedrock of any good analysis: understanding data types. Seriously, if you get this wrong, everything that comes after it is pretty much meaningless. You could think of it like learning the basic grammar of a language before you even try to write a sentence.
So let me ask you this. What's the number one single biggest mistake people make in data analysis? It's probably not what you think. It has nothing to do with some complex algorithm or a super expensive piece of software. Nope, it's something way more basic, and it happens right at the very beginning.
And this is exactly why it's such a big deal. Getting the data type wrong isn't just a tiny error you can fix later. It's a foundational flaw that can completely tank your entire analysis. You end up building bad models, drawing the wrong conclusions, and generating insights that don't just fail to help, they can actively mislead you.
This whole situation is what we can call the data type dilemma. Before you even think about building a chart or training a machine learning model, you have to hit pause and ask the most fundamental question there is: what kind of data am I actually working with here?
Because, you see, figuring out your data's type dictates literally everything else you do. It tells you which statistical methods are even valid, what kind of charts will actually make sense, and which machine learning models you're allowed to apply. It is the very first domino that has to fall correctly in any data project.
So with that in mind, let's meet the main characters in our data story. For the most part, you're going to run into 4 major types of data out there in the wild, and really getting the difference between them is the whole key.
First up, we've got categorical data. Now, this is probably the simplest kind. Just think of these as labels or tags. Their job is to put things into different buckets or groups, but, and this is important, those groups don't have any natural order or ranking. They're just different from each other.
For example, right? A product category like electronics isn't mathematically greater or less than apparel. And the country Canada doesn't have some kind of numerical relationship with the USA. They're just distinct, separate labels. And that, in a nutshell, is categorical data.
Okay, next up, we have ordinal data. Now, at first glance, this might look a lot like categorical data, but it's got one crucial twist. Here, the order actually matters. The categories have a meaningful, logical ranking from low to high, or small to large.
A classic example is a satisfaction survey. We all intuitively know that high satisfaction is better than medium, and medium is better than low. There's a clear order there. But, and here's the key thing, the gap between low and medium isn't necessarily the same size as the gap between medium and high. The intervals aren't equal.
And now, let's get to the one we're all familiar with: numerical data. These are your classic numbers, things you can actually measure and, you guessed it, do math on. You can calculate an average, a sum, a standard deviation, and it all makes perfect sense.
Now, numerical data itself actually comes in 2 main flavors. First, you have discrete data. This is anything you can count in whole numbers, like the number of clicks on a website. You can have 3 clicks or 4 clicks, but you can't have 3.5 clicks. Then you have continuous data, which can be any value within a range, like temperature or a person's height or weight.
And finally, we have binary data. This is the simplest of them all. Really, it's just a special, stripped-down version of categorical data where there are only 2 possible outcomes. It's either one thing or it's the other. That's it.
And you see this everywhere, especially in business. Did a customer churn? Yes or no? Was a transaction fraudulent or not? This simple yes or no, on or off structure is the absolute foundation for tons of classification problems in machine learning.
Okay, so we've met the data types, but you might be thinking, so what? Why did we just go through all that? Well, let's put this knowledge to work and see exactly why getting this right is so incredibly critical.
This table right here is basically your roadmap for what you can and cannot do. Just look at the row for mean or average. You simply can't calculate the average of categorical data. I mean, what's the average of USA and Canada? The question itself is meaningless, and trying to average ordinal data is super risky because those intervals between the ranks aren't equal. Just following these simple rules will help you avoid so many common mistakes. You know, this isn't just about abstract math either. It's about how you tell a story visually. The best charts, the most honest visualizations, are the ones that respect the true nature of the data. You can't just toss any old data into any chart and expect it to tell you the truth. So here's the rule of thumb. If you have categorical data, like different browser types, a bar chart that shows you the count for each category is perfect. But if you have numerical data, like customer income, then a histogram that shows you the distribution, how that income is spread out, is the right tool for the job. The data type itself points you to the correct visualization.
And when it comes to machine learning, well, this stuff is absolutely non-negotiable. Machine learning models, at their core, only understand numbers, so you have to translate any non-numeric data using a process called encoding. That means turning a label like Chrome into a number the model can actually work with. But you have to be careful. If you use the wrong encoding technique on ordinal data, you could accidentally destroy the very ranking that makes that data useful in the first place.
Ultimately, understanding data types isn't just some technical skill you check off a list. It's about protecting yourself and your organization from being fooled by bad analysis. It's what separates a company that is truly data-driven from one that's just data-confused.
And with what you know now, you can start to spot these mistakes from a mile away. One of the biggest offenders? Seeing someone treat a zip code, which is just a categorical label, like a number and trying to calculate the average. Or someone assuming that survey ratings of 1, 2, and 3 have equal meaning between them. These errors are everywhere once you know what to look for.
I absolutely love this quote. It just frames it so perfectly. Data typing is essential analytical hygiene. Just like a surgeon has to wash their hands before an operation, a data analyst must correctly identify their data types before they even begin to work. It's a fundamental step for a clean, valid result.
So if you only remember one thing from all of this, please make it this. The very first question you should ask of any new data set is, what type of data is in each column? Don't just start looking at the values. First, understand their fundamental nature. So the next time you open up a spreadsheet or connect to a database, don't just see a bunch of rows and columns. Stop for a second and ask yourself, do I actually understand the language this data is speaking? Because now you have the key to translate it.